Hello guys, you are welcome to the GMAETS 41's online class. This morning I woke up and as usual needed to check through what our class was like, the previous class we had, and it was quite unfortunate, right? I was saddened to see that some part of the lesson, the lecture I had with you guys yesterday did not show up, like it didn't upload completely. You can see this on the board, right? I actually solved this question and I thought that, the class was going on well, although I experienced network challenge yesterday. But all the same, I just noticed that of a class of, there are about 50 minutes or so, only a clip of 19 minutes was made available on YouTube. That, of course, is as a result of network. I am certain of that. Therefore, as always, like I said, the GMAETS 41, I am here to always give the best to students. I know that friends who connected to the class at the earliest time, would actually have been expecting a lot. But unfortunately, network, messed us up. But then, to make up for the class, I decided to host this particular class, although without prior information, because I believe that anybody who follows up with GMAETS 41 should be a subscriber and should have turned on the notification bell. I've always said this time and again, so that once I kick off any class, YouTube will personally notify you. So I want to believe that as many as are there would get a notification about this class and connect. Yeah, this is an online school. So this is what we are going to do. When I went through the clip, I found out that some part of the video lesson, the introductory part, the things students need to know about limit of a function, because that's what the class is based on. In terms of definition of limit, in terms of certain things you should know about when zero is used to carry out an operation. For example, multiplying a number by zero, right? Dividing a number by zero. Then dividing a number by infinity, multiplying a number by infinity, adding infinity to a number. Those aspects, okay, they appeared in that clip that was made available. Okay, so we'll be referring to this particular live class as part two of that supposed class yesterday. Okay, this is just to make up for the class. And so without wasting time, we shall be moving on to solving questions right away. And I've got some wonderful questions here, just to have some good time with you guys, at least as a way of making up for the yesterday setback. For friends in Nnamdi Azikiwe University, UNIZIK, I am going to be solving questions, okay, drawn from your Math 102 workbook based on limit of a function. Please permit me, let me send the information about this class to our WhatsApp group so that others can get to know about it. And if you are free wherever you are, could be you are in school environment now, but perhaps lecture is not in progress, what stops you from connecting to this class right away and learn something good? Okay. Let me send a message, please. Okay, so I have to leave this on the board for you to see what I was actually talking about. This part and many other were cut off from the lesson yesterday. So let us make up for it, please. There's no time. We'll be wiping this now, still on the concept of limit of a function. Still on the concept of limit of a function. Okay, so I've got this, like I said in that lesson yesterday, for full lecture on limit of functions, because there are some key things you need to learn, please. You would want to check the description section of this particular video lesson at the end of the class so that you can see the link to the full lecture on limit of functions. For now, I'll be moving on straight to solving questions on it, so you try to follow up. Now, the first question that we are going to look at here, okay, let me just deal with this particular one, okay? This particular one is not from the workbook. It's not. But based on one or two things I explained in that lesson yesterday. So you are asked to evaluate limit of 8 as the independent variable approaches 2. Limit of this function. Evaluate. Limit of this as the independent variable approaches 2. Now, how do you solve this problem? Solution. This function given to us is a constant. You can say that. Just 8. It does not depend on x. It does not depend on the independent variable. It doesn't depend on it. So if you are asked to evaluate the limit of this constant function as this independent variable approaches 2. Now observe, look at this function. Is there any x in the function for you to substitute this to? No. It simply means if you are evaluating limit of a constant, I talked about that in that yesterday class. Limit of any constant as the independent variable tends to anything, tends to any number, is still that constant. Is still that what? Constant. So this is just the answer to this particular question. The reason is because the function, that constant function will not change. When you talk about constant, that thing remains the same. Even if I ask to find the limit of this function as x tends to, let us say, 3, the answer will still remain 8, that constant function. Okay, let's move on to another question. Question number 2. Just want you to get a little idea of this before we move on to other questions that somehow might seem tough, but of course they are 1 plus 1 with GMAETS 41. Now we are looking at this second question. We are asked to evaluate limits of the function. Perhaps let me put the question this way. In a way that perhaps if someone sees it, you just kind of maybe worried a bit. Given that f of x is equal to, let's say, the limit of x squared plus 5. F of x is equal to limit of this. Now evaluate this f of x equal to x squared plus 5. Evaluate limit of f of x as x tends to -1. As x tends to -1, evaluate the limit of this function. So it's a simple thing to do. I'm going to make use of this part, solution. And we are given the function, look at it. So when we are asked to evaluate the limit of this function, it is the same as solving for limit of x squared plus 5 as x approaches -1, tends to -1. That's what we are asked to evaluate. So what do? Simply go on, and wherever you see the independent variable x, fix the given value that the independent variable is approaching. So this is going to be limit, open bracket, in place of this x, you fix -1, and then you know that that -1 is squared, so you have to square it, plus 5. And so this is equal to, simplify this term that you have here. If you are simplifying, Minus 1 square is going to give you 1. Then 1 plus 5 will give you 6. We conclude that the limit of f of x as x tends to minus 1. Limit of f of x as x tends to minus 1. Given that f of x is this function x squared plus 5, the answer is 6. I have shown you some things about limits. You can see that. So you see clearly that the whole idea of limit of a function is simply you have a function and then just try to substitute the value that the independent variable is tending to. The value that the independent variable is approaching, is getting to. And that is usually always given in a particular question. Then when you substitute, just simplify. Do your normal mathematics simplification. If you have challenge with basic arithmetics and all these things about simplification, please follow me on the GMAT 41 basic class channel. The name of the channel is GMAT 41. The GMAT 41, how do you spell it? Spell it together. GMAT 41, don't space. Don't space. And don't use this hypercand. Don't. No, that stuff like hyphen. Don't use it. Just GMAT 41 together. Then you space now, write basic. Space, write class. Because in that class, since it is dedicated to scholars in basic level of learning, there I break down concepts and take it step by step by step to ensure that our little ones learn better and clearer. Okay, so if you have challenges with your basic maths, please follow me on that channel. The reason is we are moving on. There are questions we're going to see. For example, some of the Unizik workbook questions you're going to consider now. You see certain simplification in it, and then maybe you are just having certain challenge. Please, to solve this problem in basic simplification, make sure that you follow me on that channel. Let us take this next question, please. Let's take this next question. And of course, this question is actually from Unizik workbook, like I said, okay? I'm going to write a question here. Question number 3. Question 3. In this question number 3, we have this. In the thumbnail of this particular live class, you saw a question of that kind, right? So let us see what the question is all about. Now you're asked to evaluate limit of square root x squared plus 4 and then minus 2 all over x squared as the independent variable x approaches 0. As it tends to 0, you are asked to evaluate that limit. As usual, what do? Fixing the 0 there, the limit given, and then check to find out what it is going to be. If the limit of this function exists, find out, and we are going to do it together. I'll move on straight to this function, and then wherever I see x, I will fix 0, because x is tending to 0, is approaching 0. Please take note that this square root covers x squared plus 4. It does not affect this minus 2 in that problem given. If you fix 0 here, you're going to get 0 squared, which is 0. Then plus 4. 0 plus 4 will give you 4, which means you have square root of 4. Square root of 4 will give you 2. If square root of 4 gives you 2, 2 minus 2 is 0, which means the numerator is 0. All over, in the denominator you have x squared there, that's squared x, fix 0 there, and square that 0. Squared 0 is going to give you 0, which means the denominator here will give you 0. And what is the implication? If you fix this limit directly into this function, you will get 0 over 0. In our class yesterday, where we are supposed to have this major class, right? Please take note. The GMAT 41's online class is scheduled. We have timetable that we follow. On this channel, I've already released a timetable, I think, a few days ago. If you go to the post section of GMAT 41's channel, you would see the timetable. So you make sure you follow up. For example, today, I'll be teaching 200 level students ODE. Yeah, I use the word 200 level referring to those in Unizik. If you are from any other school or any other part of the world and you are connecting to this class, suppose you are offering ODE, ordinary differential equation. Connect that class. I think it's going to be around 8, is it 8:30 or 8:45 or so. Check out the timetable, you would see it. And then by 7:30, I will be teaching physics. I'll be teaching O-level student physics. Those in secondary school, right? Senior secondary school. They'll be having physics. So we have time to be guiding us. We have these 2 courses or subjects today. So this particular work I'm doing now was based on yesterday's work, but like I said, network messed us up. So we move on, please. Thank you to all you guys that have connected. You're welcome to the class. Let's move on. So like I said, if you fix the limit directly here, you get 0/0. In that class yesterday, at least the clip that was made available by YouTube due to network challenge yesterday, that clip, I explained that 0/0 is meaningless. It's a useless term, right? It is indeterminate. You don't have a solution to that. This thing is not even undefined. It's not undefined. For undefined case, you have a non-zero number in the numerator, and then you are dividing it by 0. Something like 2/0 is undefined. But if you have 0/0, right? Undefined, usually we use infinity for it. Infinity. Okay? Infinity for undefined terms. This guy is not undefined. It's meaningless. It does not make any sense. It's indeterminate. It's not something you can get. It doesn't exist. It doesn't make sense. And anytime you see something like this, I explain that you are expected to do something, which brings in the concept of hopitalRule. But then we are going to do something to this question. I will solve this problem using 2 methods. I'd like to state that in the workbook, the method that was actually presented for you to follow is solved rationalization method. But don't worry, I'm coming to that. I want to teach you the hopitalRule method first. Why? In the study of function, hopitalRule is invaluable, meaning it is extremely important. Are you following, right? So we are going to solve this question using hopitalRule first. You want to know more about when you use hopitalRule and what it is all about, please, like I said, in the description section of this particular live class, and even the one we had yesterday, okay, they have almost the same, title, limit of a function, okay? Check in the description section. You're going to see a link to the full lecture on limit of a function, okay? Because there are certain things you still need to learn about that, about limit of a function. So coming here, according to the hopitalRule, we are going to differentiate this term. Why? Because it gave us 0/0 when we fixed this limit, which means this function, directly as it is at this point, it doesn't have limit. So we must find the point where the limit of this function will exist or will occur. So applying the hopitalRule, we're using the hopitalRule, we are going to differentiate, like I said. Differentiate the numerator, differentiate the denominator separately. Are you getting me right? Don't go use quotient rule. Look at the numerator, pick them, and differentiate the terms you have there. Look at the denominator, differentiate it. The concept of differentiation on this channel, I have finished every work on it. The playlist, you have video lesson on it. Please become a channel member so that you can get access to key lectures that cover all these stuff you're doing, okay, in order to make them 1 + 1 for you. Join us on the platinum level or diamond level. The platinum level is just 2,000 naira per month, right? Nigerian currency. If you make use of any other currency, you can use the conversion index to know what it is going to be. Support this platform so that you get the best. You get access to members-only video, interaction with me, whenever you have certain academic challenges in your work, as we cover on this channel. So we are going to differentiate this. This limit will now give us the limits that they ask us to evaluate, -2 all over x squared as x tends to 0, using the hopitalRule. I'm going to write this below. This is a question I'm solving. So using the hopitalRule, I've told you what you're meant to do. Differentiate the numerator and the denominator. Wiping this, no time. If you pick this numerator to differentiate, square root of this term, anytime you have square root of a term and you have to differentiate, please, dear friends, take note of this. You are expected to convert it to something like this. Convert it to fractional index. That square root of that term is the same as x plus 4 raised to power half. Square root means raised to power half. Is that clear? So if you have a radical function like this and you're asked to differentiate, please convert that radical function to fractional index, then you now differentiate. Now we're going to use the major-minor differentiation concepts. You want to learn more about major-minor, like I said, this channel is here for you to give you the very best. Become a channel member, please. Become a channel member. You get access to all these key video lessons to guide you. Now, we are going to differentiate the major function and then differentiate the minor function. So applying the hopital rule, this is going to be limit x tends to 0. I'll differentiate this term. How do I handle it? Use the power to multiply the base. If I do that, I'm going to get 1 over 2. That is half of this base. X squared plus 4. Move to the power and subtract 1. If you subtract 1 from half, you're going to get minus half. You're going to get power minus half. Now I am done with the major differentiation, where I use the power to multiply the base and then subtracted 1 from the power. It's a simple work to do. Basic arithmetic, multiplication, and then subtract. When you are done with this, move on and differentiate the minor function, the base. So this is times. If you differentiate this term, x squared, you are going to get 2x. You differentiate 4, you will get 0. So derivative of this x squared plus 4 alone is going to give you 2x. We have differentiated the numerator of this function. Oh no, one part of the numerator. Okay, now minus 2. We have to differentiate this minus 2. So I'm meant to put minus here, differentiate that 2. But thanks to God, this is a pure constant. If you differentiate it, you get 0. So it goes off. This will now be all over. Move to the denominator and differentiate x squared. If you differentiate x squared, you will get what? 2x. Now, mathematically, observe something. 1 over 2 times this bracket times this 2x. This 1 over 2 cannot open this bracket. It's not possible because of this power. The power is not 1. And because the power is not 1, you cannot open it. Which means this half can only multiply 2x. And if you have 1 over 2 times 2x, this over 2 and this 2 will cancel. They will divide. So what am I left with? If I decide to simplify this further, according to the hopital rule, the derivative of the numerator and denominator for this function will now give us, please observe. Okay, something else can still cancel. This x here will cancel this x. Okay, to cancel that x. I could have even just divided 2x by 2x if I want, because they are the same term. But I decide to use this one, no problem, it's still okay. Basic arithmetics. Okay, multiplication and division of fractions. That is it. All right, friends. This x squared plus 4 raised to power minus half. Raised to power minus half. If you use negative index law, yes, under indices, you are going to take the reciprocal of this. And reciprocal is 1 over the base. That is 1 over this x squared plus 4. Let's write it 1 over x squared plus 4. Then this power minus half will now become half. That minus will disappear because of the application of negative index. Now take note that there is a 2 in the denominator. So I'll bring down that 2. I'll write it down. Look at it. 2 is in the denominator originally before bringing this guy down using negative index law, And this is simply the same as limit x tends to 0 of, if I simplify this further, it is 1 all over 2 times square root of x squared plus 4. I've simplified it. So applying the hopital rule here, are you following? Differentiating the numerator and the denominator, this is what I get by deciding to punish myself to the end. You know why I use the word that I decided to punish myself? By the time I differentiated the numerator and denominator and got this, I could have fixed my 0 directly as the limit and check whether the limit of this function will exist. I really didn't need to do all this simplification if I were to be seated for an objective, a CBT examination. But you know, for full understanding and for you to follow the processes, I decided to simplify to the end. Having simplified to the end, I can now substitute the limit. So going back to the question given to us, but before I bring this down equal to whatever is going to be, please observe this. If I fix 0 for x here, will a limit exist? Let us test it and see. Limit of this function as x approaches 0. Fix 0 here, you get 0 squared, which is 0, plus 4, you get 4. Square root of 4 is 2. 2 times 2 is 4. So this whole term will be 1 over 4. And that is a real number. Therefore, the limit exists at this point. Limit of this function exists at this point. And we can now conclude. Okay, it implies that, going back to the question, okay, it implies that this will be equal to limit x tends to 0. Let's fix that value of x now and then see it simplified. 0 squared plus 4. And this is going to be equal to 1 over 4, like we've just explained. Conclusively. Going back to the question, the limit square root x squared plus 4 minus 2 divided by x squared. As x approaches 0, the limit is 1 over 4. That is the answer. So take a look at it and you can copy that out. Why I move on to see how we can use the alternative method, because this particular question, one can use solved rationalization to obtain the same result. One can use solved rationalization to obtain what? The same result. It's going to be a wonderful time, on this channel, this particular semester. So friends in Unizik, make sure you are always at alert. Stay tuned, right? Become a channel member. If you need physical tutorial, remember that GMAETS 41 also takes you on physical tutorial on campus. Today we've got a class. We have class today. Okay, so become a channel member. You can join our WhatsApp group to get updates about the classes. Send a message to this contact on WhatsApp. Request to be added to the group. You must send your name. You must send where you are contacting us from. Let's know who you are. Yeah. Okay, then send your level of learning. Tell us your school so we know where to add you to. So join our physical tutorial. For those of you that need physical tutorial, we've kicked off our classes already, our physical tutorial since Monday. Okay, today is Wednesday already. We have class today. Make sure you are there. Invite your friends to join the class. There is no time. Because say it's going to be a wonderful section with you friends, both online and physical and in physical class. You can screenshot this, please. No time to waste because I'm going to wipe it right away. So we move on to another question. Yes, Moon, you wrote it's 1 over 4. That's correct. That's correct. That's correct. Okay, so I believe that you screenshot this solving on the board. I'm going to wipe these and then we move on to the alternative method. Okay, let me wipe up to this point. I'll still wipe this. Let me start the solution from here. Alternatively, I told you the reason why I decided to carry out the hopitalRule first, because this is very important when it comes to the concept of limit. You don't joke with it. Yeah, you don't joke with it. So you take note of that. This solved rationalization method that can be used to solve this particular question. It's just in some cases that you apply such knowledge. So we have limits of square root x squared plus 4 and then minus 2 divided by square of x as x tends to 0. So we are going to rationalize this. In rationalizing, take a look at the numerator. You will agree with me that the numerator has a sodic number. So you're going to look at that numerator, get the conjugate, and use the conjugate to rationalize. This concept, we've covered it under SWORD last semester. And on this channel, you have video lessons that covers that. If you have problems on SWORD, visit that. This is why you want to appreciate this channel the most. Are you following, right? Because here, everything is there for you. You're having problem with this topic and always just, tune in, go to the playlist, scroll, check for the topic, and you take it. And these things are broken down 1 plus 1. Like I said, to get access to key lecture videos, become a channel member, please. Support this channel. I'm appealing to you so that I continue to give you the best and you continue to get the best from this channel. Go for the platinum level, take note. Don't go for the gold level. Go for the platinum level or diamond level. Going for diamond level, depending on how convenient it is for you, you want to support and appreciate me more, you can go for that diamond level, okay? So, a platinum level, basic. Yeah, basic. I will appreciate that. So, we move on. The conjugate of this sodic part, this numerator, its conjugate is simply to change this sign to plus. And then once you get a conjugate, what do you use the conjugate to do? Use the conjugate to multiply the numerator and denominator. So let me write rationalizing. Using the conjugate, I've told you, the conjugate of this numerator is square root of this whole term, then plus 2. I'm going to use it to multiply top and bottom. So this becomes limit x tends to 0, square root x squared plus 4, minus 2, then it is all over x squared. I'm going to multiply the numerator and the denominator by the conjugate of this. And the conjugate is square root x squared plus 4, then plus 2. That's good. The denominator would also be multiplied by that term, square root x squared plus 4, and then plus 2. So this is going to give us limits as x tends to 0. The numerator, watch it very well. You will agree with me that what you have in this bracket is exactly what you have in this bracket to a greater extent. In terms of the terms, they are the same. The only difference is the sign. This is minus and this is plus. So quickly, this will remind you of difference of two squares. If you have a minus b and a plus b, this is equal to, go to the part that has minus, then square each of those terms. A squared minus b squared. So we can apply it here, where our a is this whole term under square root, and our b is this 2. So square this term. If I give you square root of x squared plus 4, and I say you should square it, what is going to happen? The square will cancel this square root. You'll be left with x squared plus 4. So I'll come over here and then I'll write, this is x squared plus 4 from this part. Then you square these 2. Make sure you maintain the sign minus. So I'll write minus and then square these 2. Look at it. You don't touch the minus when you are squaring. It's a follow count. Pick this term, square it. Pick this term, square it. If I square that 2, I'm going to get 4. So you see this term, x squared plus 4 minus 4 is the value of your expanding this bracket. You can take your time to expand the bracket on your own, okay? But of course, while preparing for exams and all these things, I want to believe we are past this stage already. This is all over. The denominator will be x squared, open bracket, square root, x squared plus 4, and then plus 2. I don't need to go use this to multiply any term there. I have rationalized. I can simplify this term. If I simplify this, it's going to give me limits. I'm trying to show you all steps and everything. Limit 4 minus 4 is 0. So you are left with only x in the numerator. If I have x all over x squared times this whole bracket, the x in the numerator and the x squared in the numerator and this x squared will cancel out. And if they cancel out, what will be left on top will be 1. Just simply x squared divided by x squared, you get 1. But before you divide this by this, you must have simplified the numerator. 4 minus 4 is 0. It goes off. You are left with x squared. Then you divide through. So the numerator is left with 1 all over the denominator, which is x squared plus 4 and then plus 2. This is cool. I have done the rationalization completely. It implies that limit of this term will now be equal to fix up the value of that limit. Limit as x tends to 0 of this term, you fix your 0 wherever you see x. So this is what we are going to get, plus 2. Let's conclude. This is going to be equal to square root of 0. Oh no, 0 squared is 0. Plus 4 is 4. Square root of 4 is 2. 2 plus 2 is 4. So this is 1 over 4. We can now conclude, going back to the question given to us, the limit of x squared plus 4 minus 2 all over x squared as x approaches 0. The answer is 1 over 4 as before. So you see any of these two methods solve this particular question. You can take down what you have on the board. Better for you, you screenshot. If you're a ZKite, a Unizik student, you need this. This particular pattern was the pattern, okay, required that you use in solving this question that I just solved. The only thing is that, you know, in the workbook, they present spaces for you to fill some things. Does that make sense, right? I just like to show all working. In that workbook, there are some lines that, you know, were not required for you to put there, okay? So, all the same, my interest is not really to follow all those step-by-step something. Like I told you on this channel, the solution of your Math 102, Math 102, Physics 102, they are available now. Yes, once it is time, the video lessons are available. So once it's time, I just release them, right? And then you can enter them, but make sure it's not just to copy. On the rent. I'm not saying you are lazy, but if anybody is lazy, the person knows. Don't just end up copying things. I detest that. I don't like it. The reason I do all these things is just to help you understand this, learn them, so that, you know, you can always prove it any day, anytime, whether it is in exam hall or anywhere. Remember, in exam hall, I will not be seated with you. Yeah, I will not. Okay, so I am done with this question. I hope you've learned how to deal with this particular question. Finish it up. Let's move on, please. So the next question I would like us to solve. We are 38 minutes gone. This class, I don't want it to last beyond 1 hour. Let me adjust the camera a bit to capture the left part completely. Let's see. All right. So finish up. I believe you screenshotted it. And so we are going to move on to the next question. Going to move on to the next question. Okay, so I'm going to wipe this part. The person that is requesting for organic chemistry, the channel already has finished everything about the organic chemistry. They are there on this channel, okay? Slide through the playlist. You can also go through the live section of this channel. Am I communicating? You can go through the live section of this channel. You would see wonderful works on organic chemistry. Is that okay? Okay, bros, trying to be the new organic chemistry tutor. I really don't understand that anyway. Okay, let us move on. The next question I have here, that's going to be question number 4. Still Unizik workbook on limit. And you are asked to evaluate this particular, you know, this limit problems. I think they are on module 1 of the workbook. I don't know, except if they decide to reshuffle the modules, but all the same. Let's go. Evaluate limits of 3 over x squared plus 1, no, x cubed plus 1 as x tends to infinity. As x tends to infinity. As x tends to infinity. So we're going to solve this and see. We are evaluating limit of the function 3 over x cubed plus 1. The independent variable is tending to infinity. So what do? Quickly substitute. This is equal to limit x tends to infinity. Wherever you see x, you fix infinity. So this is cube of infinity plus 1. And that's going to give us, if you simplify that term, limit x tends to infinity, and then you have 3 divided by infinity cube is infinity. Infinity raised to power 3 is infinity. Add 1 to it, infinity plus 1 will still give you infinity. Please, you need to know about the properties of 0 and infinity. You need to know about the properties of 0 and infinity, the full lecture. If you divide 3 by infinity, you are going to get 0. Is that okay? So I can now conclude that limit of 3 all over x cubed plus 1 as x tends to infinity. The result is 0. That is it. We move on to the next question, number 4. If you're yet to subscribe to this channel, do yourself good, subscribe, okay? And then turn on the notification bell so that once I upload any content or I host a live class as this, you will be personally notified. Let us move on to the next question. We are asked, question number 4, right? Okay, question 5. We have to evaluate, okay, find the limit of the function f of x equal to exponential 3x minus 1 all over x as x tends to 0. I'm going to write out question 6 as well too. Evaluate limit exponential 2x minus 1 all over x squared as x tends to 0. Now for question 5, the answer is 3. For question 6, the answer is 2. Find out. Solve and drop your solution in the comment box. You have to show your working, when you are doing that, try to type your solution. Show your working. Why is it or how is it that this question 5, the answer is 3, question 6, the answer is 2. Is that okay? I'd like to see what your comment is on this, based on what you've learned so far from this class. And I'm glad that we've been able to cover the concept of limit of a function. You want to learn more, like I said, you have the link to the full lecture on limit of a function. Become a channel member, support this channel so that the channel will continue to move further and give you the best, right? Remember, if the channel does not move further, you wouldn't get the best, because how would the best come? Support me, support GMAETS 41, and then of course I would always be here to give you the best. If you become a channel member, there are so many benefits you gain from it, and one of the most important benefits is you get access to all the GMAETS 41's video lessons, topic by topic, according to the courses that you are offering. Which means if you have any challenge from your studies or whatever, you can easily, come and make up your knowledge from this channel. I hope to see you friends later, right, in the evening. For those in O level, we'll be having physics. But remember, 100 level students, O level works, you also deal with them in your Physics 102, right? So you can tune in and check if it's a topic you are dealing with. And then those in 200 level, any student offering ODE, ordinary differential equation. I'm also having class with you this evening. Stay tuned. If you have not subscribed and turned on the notification bell, do that right away so you don't even forget. Are you getting me right? Like I said, become a channel member so you can get the best video lessons meant for members only. And of course, you can make certain specific requests as for what you want GMAETS to work on for you, and I will do that for you. Thank you, all of you that connected, and I hope to see you later. Have a wonderful day. For ZKite, like I said, if you're in Unizik, place 100 level students, today we are having our physical tutorial class. You want to become a member of GMAT 41 fully, come for the class. In fact, it's not issue of you want to become, I'm inviting you to come. Okay, you will love it. You will appreciate you did become a member, even joining our physical tutorial. At the end of everything, the goal is simple. Get these students prepared for their A splashes and first class. And that is what this channel is meant for. The channel speaks volume for itself. And you're aware of that already, okay? I'll be seeing you later. The country lover, derivative of exponential 3x equal to 3 exponential 3x, and derivative of putting x equal to this, you get 3. Okay, that's good. That's good. The class will be ending now, so you can come back and drop your comments in the comment box. Like I said, all these comments being dropped right now, this live class, at the end of it, they'll disappear. Okay, they'll go off. So come and drop your comments just at the end of this class. Can go to the comment box and leave your comment there. Bye-bye.